Good afternoon, everyone. So, today we are going to start the week two of this lecture series. So, today we'll discuss questions based on the week one, and also we will solve some of the gate question. Like first, we will solve some of the questions from NPTL, and after that, we will solve a few questions from the previous year gate. So, the first question is Fourier series can be found for. So, we all know that Fourier series is found for the continuous time periodic signal. So Fourier series is found for continuous time and periodic signal. So the option C is the correct option for the first question. Now the second question is the power of an energy signal. So the power of the energy signal will be 0. So option A is the correct for this. These all are very simple question. So option A is correct. So we know that the formula for energy is minus infinite to infinite x of t magnitude square dt. Now for power, Px is equal to limit t tends to infinite 1 by t minus t by 2 x of t square dt. So if this part is finite, then this is known as the energy signal. Now when you divide 1 by t here in the if you divide by 1 by t here in the energy signal and t is tending to infinite, so in that case, the power of the energy signal will become 0 because some finite quantity divided by infinite quantity will be 0. So for this question, the option A is correct. So in this question, consider the Fourier series of a signal xt with fundamental frequency f naught is equal to 2 hertz. It is given. The fundamental frequency f naught is 2 hertz. The coefficient in Fourier series corresponding to the term e to the power of j 8 pi t. So in this question, if f naught is given as 2, is implied that the t will be 1 by 2. And let's suppose the LH coefficient CL in the Fourier series corresponding to the term e to the power of j 2 pi L f naught t. Okay. So f naught is 1 by 2. So this will become e to the power of j 2 pi. F naught is 2. That will be 4 pi and 4 pi and t is also 1 by 2. So that will become 8 pi. So, so the LH coefficient that will become here 2 pi F naught is 2 and t is 1 by 2. So 2 into 2, 4, 8 pi. So this will be e to the power of j 8 pi t. So we all know like the Fourier series can be written as here 1 by t minus t by 2 to t by 2 xt into e to the power minus j 2 pi l f naught t. So L because it's the Lth coefficient dt. So this we can write as t is 1 by 2, so 2 minus 1 by 4 to 1 by 4 xt into e to the power of minus j 8 pi t. Okay, and now when we equate this term e to the power minus of j 8 pi t equal to equate with this the Lth coefficient, that is e to the power of j of 2 pi l f naught t. Here you put f naught is equal to 1 by 2. So you will get 8 pi t is equal to e of j of 4 pi l t. So the value of L equate from here, 4 pi l t is equal to 8 pi t. So L is equal to 2. Okay. So for this the correct option is this one. So option number B is the correct option for this question. The next question is consider a periodic signal xt with period t naught and Fourier series is given as summation ck e to the power of j 2 pi f naught t, and f naught is equal to 1 by t naught. So they are asking the Parseval's theorem states that. So we have studied in the week 1 lecture the Parseval's theorem is given as 1 by t naught summation of integration of 0 to t naught xt square dt is equal to summation of ck square, k in minus infinite to infinite. So this is Parseval's theorem. So which option is correct in this? 1 by t naught, 0 to t naught. So option C is the correct option for this question. So these things are like already taught in the proof of this was already taught in the classroom. And also this is also equal to the power of the signal, that is equal to summation of all the coefficient k ranging from minus infinite to infinite. So this is also equal to the power of the signal. So now the next question is asking direct delta functions on the direct delta function. So we all know that direct delta function exists at t is equal to 0 only. At all other location, it is 0. So the integration over t is equal to minus infinite to infinite, the integration value will be 1. So the correct option is option D here. So it is just an impulse at time t is equal to 0. At all other location, the value is, so del t is equal to 0 for t is not equal to 0 and is equal to not defined for t is equal to 0. And also this direct delta function can be written as, this is let's suppose minus 1 by 2t and this is 1 by 2t. So the width is 1 by 2t minus of 1 by 2t. So that is equal to 1 by t. So this width is 1 by t. So the height will be also, height is in like inversely proportional, like inverse of the width. So height will be 1 by 1 by t. So that is equal to t. So now you find the area of this. So area is equal to 1 by t, that is the length into width. Length into width into height. So 1 by t into t. So this value is equal to 1. Same here, if you integrate it, you will get it as a 1. Like let's suppose here we keep t tends to infinite. If t tends to infinite, then 1 by 2t will be almost 0. So in that case, this will converge. This direct delta function will converge in at t is equal to 0 only, because 1 by 2t will also tends to 0. As t tends to infinite, 1 by 2t tends to 0. So at t is equal to 0, this value is t. So this t is equal to infinite. So this is not defined here in this case. The correct option is option D. So now given the complex signal 1 by 2 plus jt, and we have to find the energy. So for signal xt, energy is given as integration of mod of xt square dt. So xt is given as 1 by 2 plus jt. So the magnitude of xt will be 1 by under root of 4 plus t square. Now when we square it, we will get 1 by 4 plus t square. So energy will be is equal to minus infinite to infinite dt. So we can write it as, now after this integration we will get tan inverse t by 2 from minus Okay, so we are taking here 4 common. So this 4 will be, just I have one mistake. So from here, let's suppose we take 4 common. So it will be 1 plus t square by 4, that is equal to t by 2 square dt. And this function is even function because see 1 plus t by 2 square is even function. So now integration we will write it as 2 into 1 by 4 1 by 1 plus t by 2 square dt, and this limit will change from 0 to infinite because it's a even function. So if we integrate over negative side and positive side, both will be equal. So that's why we have multiplied with by 2. So we will get 1 by 2, 0 to infinite, 1 by 1 plus t by 2 square dt. So that is equal to, now we can take t by 2 as tan theta, and then we can like substitute t by 2 is equal to tan theta, we'll integrate. So after doing that, we will get 2 into tan inverse t by 2, and value of t is from 0 to infinite. So the answer will be tan inverse infinite will be pi by 2, and tan inverse 0 will be 0. So pi by 2 minus 0. So for this question, the correct option is option number 2, that is pi by 2. Now, what we have studied, like power of energy signal is 0. Energy of power signal will be infinite. Okay, because in the question you see, in the formula you see, let's suppose this is finite value, then this is a power signal. To get energy, we have to multiply here by t, and t is infinite. So if you multiply finite with infinite, you will get infinite. So energy of the power signal will be infinite. So in this question, option B is correct, that is infinite. Now we have to find the Fourier transform of signal xt is equal to half for the value of t is from minus 2 to 2. And for that, we have to find the Fourier transform. So we'll solve this question. So first we'll draw the signal xt. So this value is half for t is minus 2 to 2. So xt is equal to half if t is greater than minus 2 and less than 2, equal to 0 otherwise. So we have to find the Fourier transform of this. So xf, that is the Fourier transform of xt, like xt is xf. So xf is given as integration minus infinite to infinite xt dot e to the power of minus j 2 pi ft dt. Okay, so now the value of xt is half in the range of minus 2 to 2, and for all other value it is 0. So the integration will converge from minus 2 to 2 and xt value is half e to the power of minus j 2 pi ft dt. So this will become half e to the power of minus j 2 pi ft divided by minus j 2 pi f. And this value is from minus 2 to 2. So here it will become e to the power of, now substitute p is equal to 2 and minus 2 here. So we will take all this constant term outside. So 1 by minus 4 j pi f will take outside. Here we will get e to the power of minus j 4 pi f minus e to the power of, now when you substitute equal to minus 2, this will become plus e to the power of j 4 pi f. Okay, so this will become, now we know that e to the power of, I will add one extra page. We all know that e to the power of minus j 2 pi f t by 2 minus e to the power of j 2 pi f, this is equal to, or just take the numerator part only. So this value is equal to minus 2j sine 2 pi f t by 2. Okay, so here also we will get minus 1 by 4j pi f, and this will become minus 2j sine 4 pi f. So now j and j will get cancelled, and this minus and minus will get cancelled. So finally we will get sine 4 pi f by 2 pi f. Okay, so this we can write as 2 into sine of 4 pi f by 4 pi f. We have multiplied by 2 in numerator and denominator. So now this term, what is the option? So actually this option A is given here, that is similar to this. We don't have to do anything extra now. I was thinking to convert it into sync, but here the correct answer will be sine 4 pi f by 2 pi f. So now, and also we can write in the form of sync also. Here we can write 2 sine 4 pi f by 4 pi f. We all know that sync of x is equal to sine of pi x by pi x. Okay, so here x is 4f, so that this will become sync of 4f. So this will become 2 into sync of 4f. We can write in terms of sync also. So now we'll move on to the next question. So consider the trigonometric series representation of a periodic signal xt with fundamental frequency f naught given as this a naught plus like this. So they are asking the coefficients bn. So in this question we have to find the coefficient bn. So for this question, the value of bn is always equal to integration of xt into sine of 2 pi f naught t. So this formula you remember. Integration is over minus 1 by 2 f naught to 1 by 2 f naught. So bn is equal to xt is given as a naught plus, so in this way we can write, no, we missed the second term, that is sine of 2 pi, here it will be n also, 2 pi n f naught t dt. So bn is equal to, so this question we can discuss tomorrow. Actually, I also forgot the formula. In the next session, we'll discuss this question. Just the Fourier series formula we have to go through and we have to solve. Now the question number 10, that the Fourier transform of signal PTT is equal to 1 for mod of t less than t by 2. So here the signal is given like this, minus t by 2 to t by 2. The value of PTT is 1. And for all other values it will be 0. So PTT is equal to 1 for t is greater than minus capital T by 2 to less than T by 2 and equal to 0 otherwise. So this is simple a rectangular pulse. So the Fourier transform we can find also like as we have discussed here, like how we have discussed here, we can find the Fourier transform, or we can directly write like this. The Fourier transform will be T, like that is the width into sink of f of t. So the Fourier transform rectangular function is width into area, and that will be inside the sink function. Sorry, I have we can see whenever rectangular function is there, I'm just giving you a shortcut. You can solve in any exam. Like I will give you the general term. Let's suppose this is the rectangular function, and the value is given here minus tau by 2 to tau by 2. Just take any tau value. It may be t or it may be minus t by 2, whatever. And this value is a. Let's suppose amplitude is a. Okay. So if this is our PTT, then the Fourier transform of this will be like PTF is equal to, see, this is width and this is height. So width is equal to tau and height is equal to a. So the Fourier transform will be area, that is a into tau, that is the area of rectangle. See, a into tau is area of rectangle here, into sink of f into tau. This is the length of signal. Here also write length. So for any question you can solve like this. So let's see the previous question. The previous question was like this. So what is the width here? Length here. Length is equal to 4 and height is equal to half. So area is equal to 4 into half. This is equal to 2. So what will be the Fourier transform here? A tau sink of f tau. So A tau is the area. Don't get confused. Here I will write area instead of A. So the area is equal to 2 into sink of f. F will remain as it is. And here tau is the length, that is 4f. See, after calculation we got 2 sink 4f, and here just a shortcut. This shortcut is a generalized shortcut. So you remember this. This is very, very important. It will solve lots of time in GATE examination also. So this you remember. This is very, very important. And also there was lots of like theory discussed on the autocorrelation and the Fourier transform of autocorrelation. So I will just give you the properties of some autocorrelation function that was not discussed in the class, but it will be helpful in GATE examination. First of all, autocorrelation is given as Rx tau is equal to, like it is denoted like this. So you can write in terms of mean also, that is x of t into x of t plus tau. And also as discussed in the class, that R11 tau, that is the autocorrelation function. Autocorrelation means uh, similarity of the signal with itself. So it is a self similarity of x1t. Okay. So R11 tau is equal to x1 tau into x1 t minus tau dt. So these both are same. So we'll see some of the properties. So first properties is autocorrelation function is even function. So Rx of tau is equal to Rx of minus tau. Second is Rx of 0 is always greater than equal to Rx of tau. This means the autocorrelation function will be something like this. So this value will be Rx of 0 and that will be greater than Rx of tau for all value of time. And we have also studied in class as Fourier transform of Rx, like autocorrelation function, is equal to power spectral density, that is x Sxf. And in so inverse, so what will be the inverse Fourier transform of power spectral density? So that will be autocorrelation function. So Rx tau is equal to inverse Fourier transform of Sxf. So it will be, we can write the formula of inverse Fourier transform, that is e to the power of j 2 pi f tau v, and Rx 0, when you substitute the value of tau is equal to 0, we will get minus infinite to infinite xs xxf, that is power spectral density, df. So this value is the power, because this is integration of power spectral density for all frequency. So this gives us the power. Okay. So this is proved also in the classroom lecture. So we can stop the lecture here only. I will share these notes and the link uh, of this video, which will be uploaded on YouTube. Okay, I did not see the comment. Okay, you have solved the question. Okay, nice. So, okay, we'll meet on next Saturday and we'll solve lots of question on amplitude modulation, AM, PM, and FM on next Saturday. Thank you everyone for attending today's lecture.